Hello, my name is Mateusz and I am the product manager of AWS on Golem. We announced we are working on Ray integration with Golem a while ago, so I bet you are all very curious how we are doing. The video shows you that Ray makes it easy to parallelize your Python code and that it can be run on Golem. Let's consider this Python code. It looks weird, but generally it generates a bridge deal and then calculates potential winnings for every player and every trump suit, and then repeats it for 50 times. Let me just run it. Basically, the code doesn't know anything about Ray nor Golem. When running it on my own laptop, it takes 7 seconds. Believe me when I tell you that the calculation of 500 deals takes 1 full minute. I will now parallelize this up with Ray. First step, we need to import Ray and init it. The empty parameters tell Ray to tell the app to use the available Ray cluster or to start a local one. Okay, let's see if it works. Okay, excellent. It started local Ray instance, and then it proceeds. So let's go back to coding. We run getDeal method a lot. The executions don't depend on each other, so this makes it a good candidate for parallelization. So let's decorate with at Ray remote. It tells Ray that this method can be scheduled to run on a different worker. After the decoration, we can't call the method as before. We need to explicitly acknowledge that it will be run somewhere else. And also, we are not getting the results directly. We are getting an ID, a future that will allow us to get the results later. Basically, our original code run new get deal only after the previous one ended. Yeah, with Ray remote calls, it schedules the execution and immediately moves on. So we need to wait for the results. The output should be similar enough. So Ray parallelized the execution. So now the thing that took 7 seconds, now took a little less than 5 seconds. It is because Ray parallelized this code to run on my 8 cores of my laptop. Yeah, a bit faster, but still, this is only the beginning. Now it's time for Ray clusters. First, I will show you a Ray cluster running on AWS. There is a cluster definition YAML, which I don't want to go inside in this video. But basically, we are telling Ray to bring the cluster up. Yeah, so let me run it. As it takes a moment, let me switch to Golem. We are aiming at the same interface with Ray up and our Golem cluster YAML. But for now, I'm running the cluster manually. So it simply deploys one Ray head node and 11 Ray workers. So in total, I will have 12 nodes. So as it is starting up, let's check up on our AWS cluster. It's also starting. Okay, AWS cluster is started. Basically, it has only the head node, and it will add the actual Ray autoscaler will add new nodes during the computations. So I added some cluster information printing and increased the number of deals to 500, and let's see how it will run. So you do it by Ray submit the cluster YAML and And let's see. So I want to show you the autoscaler. So let's wait for it. This is some information about the cluster that AWS Cluster Manager prints. See, it has one node and two CPUs in total, and now it's computing. And now you see this is the autoscaler. It is now adding five nodes. Yeah? It will take some time. So the computation finished. It took some time. There are 6 nodes and 12 CPUs. Now let's rerun the computation with bigger number of deals at the same cluster. So yeah, let's do it quickly. So it doesn't terminate the clusters that are the nodes that are waiting for us. It has some time until Ray decides that nodes are not needed anymore, and then closes them down. See, it's still 6 nodes and 12 CPUs. So let's leave it. Our Golem cluster is already running. Important thing is the port 10,001, the support that we need to provide to Ray init, so that it doesn't start a local cluster, but connects to our cluster. Let's see how it runs. Yeah, see, it had 12 nodes and 42 CPUs. Yeah, we got lucky with the providers this time. Let's wait a moment, yeah, and see. Yeah, it compares the 500 deals in 10 seconds. Let's change it to change the number of deals to 2,000 and run it again. Okay, let's wait for the results. Now both computations are finished. Amazon did their job on 12 CPUs. Ray on Golem did their job on 42 CPUs. You can see a small time difference, but right now it's not important if the machines are better or worse, and why the difference. What is important that we have successfully run Ray cluster on Golem, and that it can run Ray applications. We are now working on pre-alpha release with Ray on Golem cluster, being started with Ray app command, like you saw with AWS, and with Ray autoscaler deciding when to add or remove the nodes. That way, we want to make a developer journey of running their Python code on Golem smoother than ever before. I hope you enjoyed this. Stay tuned. When we have the happy path working, we will be looking for people to try it out. See you on Ray on Golem Discord channel. Bye-bye.